Hi there. Imagine that one day, scientists sitting in observatories confirm that a large asteroid is flying towards Earth. Countries with space programs urgently need to agree on how to stop it. The following sequence of events depends on how much time, according to astronomers, remains before the collision. But none of the possible solutions will be simple, and at least one of the options will require the use of nuclear weapons. To begin with, let's define what is an asteroid. How does it differ from a meteorite or a planet? The smallest of these is a meteorite, more precisely a meteoroid. This celestial body is larger than cosmic dust, but less than 100 feet in diameter. When a meteoroid enters the planet's atmosphere, it rubs against the air and it heats and flares up. Flaming meteoroids we then call meteors or shooting stars. Usually they burn up, but sometimes they reach the surface of the Earth. Such cosmic stones are called meteorites. The asteroid has two characteristics. Firstly, it moves around the star in its own orbit. And secondly, the diameter is 100 feet or more. There's no upper bound. But the same can be said of any planet, so what's the difference? You'll be surprised, but the whole thing is in its shape. Planets are called celestial bodies, which under the influence of gravitational forces have become round. Asteroids simply don't have enough mass for this, so they just look like ordinary cobblestones, but very large. The collision of asteroids and comets with the Earth is often considered as one of the possible causes of the extinction of mankind. In the past, our planet took on the impacts of 6 asteroids with a diameter of at least 33,000 feet. This is evidenced by the huge craters on the surface of the Earth in different parts of the world. The oldest crater is 2 billion years old and the youngest is 50,000. Thus, the question is not whether the collision will occur, but when it will happen next time and whether we'll be ready for it. In the fall of 2008, an asteroid with a diameter of 7 to 16 feet fell in a desert in northern Sudan. This was the first ever predicted fall of an asteroid. One of the observatories in the United States discovered it the day before the fall, calculating the trajectory, place, and time of collision with the Earth. Everything happened exactly according to the predicted scenario. There were no casualties and no destruction. But what will happen if an asteroid 1,000 times larger flies to Earth? The asteroid linked to the extinction of the dinosaurs was 33,000 feet in diameter, and most of the biosphere survived this event safely. 2.2 million years ago, a comet with a diameter of about 6,500 feet fell into the ocean between South America and Antarctica. A wave about 3,000 feet high ejected whales into the Andes Mountains. However, the human ancestors who lived in Africa at that time were not affected. Life on our planet is unlikely to be destroyed by a large asteroid, but it is quite capable of causing a disaster on a planetary scale. If a celestial body enters a thin area of the Earth's crust or into the lid of a magma cauldron, it can provoke eruptions of volcanoes. Collisions with asteroids with a diameter of 3,000 to 30,000 feet will be accompanied by the release of up to several 100,000 tons of rock into the atmosphere. A powerful explosion will fill the atmosphere with dust, which will create the conditions for a so-called nuclear winter. In addition, the fall of a large asteroid will cause a worldwide earthquake and tsunami, which is dangerous primarily for anthropogenic civilization. The destruction in the fall zone will be absolute. The planet's climate will change dramatically and will return to normal only after a few years. But is this enough to destroy life on Earth? It all depends on the size of the asteroid. According to experts, to become a killer of all higher life forms on Earth, an asteroid must have a diameter of about 200,000 feet. Celestial bodies of this size fall extremely rarely on our planet, and right now there are no such large asteroids nearby. It's believed that almost all large asteroids from 3,000 feet diameter or more are known to us. The danger is mainly not they, but small asteroids from 150 to 500 feet diameter, because they're harder to observe and new bodies often appear among them. Another danger is explosions in the Earth's atmosphere of meteorites with a diameter of several hundred feet, which can cause false alarms of nuclear warning systems, or fall into missile bases. Governments of all countries of the world take these problems very seriously and take measures to avoid a dangerous collision. Recently, NASA astronomers and programmers created an early warning system for an asteroid attack, which can almost guarantee to detect any asteroid approaching us dangerously close 5 days before it flies to Earth. This period may seem insufficient to send a rescue mission led by Bruce Willis to a potentially dangerous asteroid, but this is already better because earlier scientists could only detect such a space killer a couple of hours before it struck Earth. In 5 days at least, it's possible to assess the consequences of the fall and take appropriate measures to save the inhabitants of the impact zone. With a small asteroid, everything is clear. You can evacuate the population or at least strongly recommend not to go to the windows. But what do we do with more serious opponents? Such as, for example, the asteroid Apophis. Scientists discovered the space object in 2004. Apophis' diameter is 1,200 feet, mass 27 million tons. The asteroid makes a complete revolution around the Sun in 324 days while regularly crossing the Earth's orbit. Apophis already flew past our planet in 2013. The distance between them then was about 9 million miles. It sounds safe, but in 2029 the situation will be different. It'll travel 20,000 miles from Earth. This is despite the fact that the diameter of our planet is only 7,900 miles. If you imagine space as a car park, then Apophis and Earth between them will only have 2.5 parking spaces. Under such conditions, the risk is obviously quite high. However, scientists claim that in 2029 it's going to pass us by, while the gravitational fields of our planets will affect the Apophis orbit, drawing the object closer to Earth. Returning in 2036, it flies back to back or maybe even collides with the Earth. And what happens if Apophis does collide with the Earth? No, humanity will not disappear, but the effect will be great. Scientists have calculated the force with which the asteroid will crash into the Earth. Even in approximate terms, the results are incredible. The impact force of the asteroid will be 1,700 megatons. All residential and industrial buildings within a radius of 10,000 feet could be destroyed. Just imagine what a nightmare it would be if Apophis falls near a nuclear power plant or a nuclear missile base. When falling into the ocean, an asteroid will lift giant tsunamis that will destroy coastal cities. A shock to the seismic activity zone could provoke earthquakes up to 6.5 points in magnitude and massive volcanic eruptions. I think the year 2036 makes us pretty nervous. Have you already thought out how you're going to survive in a post-apocalyptic environment? Share your ideas in the comments. The most obvious way to deal with a giant asteroid that's flying at great speed towards Earth is to send something towards it to knock it away. It's hoped that in this way the asteroid can be turned off course, and this will be enough to avoid a collision. There are other options. For example, while an asteroid is in deep space, land a rocket engine on its surface and gradually push the asteroid off its trajectory. Or for the same purpose, detonate a hydrogen bomb on it while it's a safe distance from the Earth. However, these methods take time. It takes at least 4 years to organize a flight outside the Earth's orbit, and it will take another 1 or 2 years for the spacecraft to reach the corresponding asteroid. If there's less time left, we may have to come up with something else. The first thing that comes to mind is to detonate an asteroid with a hydrogen or nuclear bomb on approach to Earth. But this is most likely an unfortunate idea, as such explosions could cause the asteroid to fragment into multiple smaller asteroids that could actually do more damage. Moreover, modern air defense and missile defense systems are not able to detect an asteroid threat, since they solve completely different tasks, such as tracking the launch of ballistic missiles, for example. In addition, the current Outer Space Treaty needs to be circumvented, as currently it doesn't allow nuclear explosives to be launched into space. But the developers of the D-Star project offer to vaporize small asteroids even from afar on their approaches to the Earth using an orbital platform created from many small lasers combined into one phased emitter. Depending on the size, this platform will be able to knock down asteroids or comets from dangerous orbits, or even completely evaporate small specimens. Their colleagues from the Light Touch 2 project focus on small asteroids, which they propose to gradually push from orbit using lasers. They want to test their idea with the help of a demo device, Atom, which will literally follow an asteroid for some time, firing lasers at it to slowly but significantly change its trajectory. While lasers and nuclear bombs can only work if the asteroid is already close enough, the effectiveness of these methods depends largely on the composition of a particular asteroid, since the evaporation temperature for each of them is going to be drastically different. In fact, apart from nuclear missiles, we still have nothing really. What'll happen if tomorrow astronomers announce to the entire world that an asteroid over 300,000 feet in diameter is flying to us from the Kuiper Belt? Will people be able to survive this impact? To prevent a catastrophe, you'll have to collect all of the technological power created by all of mankind and deliver a decisive blow, and then smash the asteroid to bits. Despite the fact that then thousands of its fragments are going to burn up when passing through the dense layers of the atmosphere, larger parts will nevertheless make their way to the surface of the Earth. Significant infrastructure damage and numerous casualties will probably occur, but there will be no talk of the end of the world. To deflect a killer asteroid from its orbit is going to cost a lot, but as long as we don't have a spare planet, we'll defend this one at all costs. What do you think about this? Be sure to write your opinions down below in the comments, and don't forget to click that like button if you like this video. Thanks for watching, subscribe for more.